and then let's do the okay. طيب, so GH 200 January, and I write the add, يعني, as you can see, يعني, the screen, when I share the screen you can see there is a date here, but somehow when I send the PDF it does not capture that. Anyhow, so January 18th 2021, and today we will do the counting. Shabab, can you mute your mics, please? Fahad وماجد, please mute your mics. Not sure if I can mute you. I can't. Okay. Majid, you are muted now. Okay. So to do counting techniques, and before we start, I have an announcement to make. Which is, we'll have quiz 1 on Wednesday. Okay, so quiz 1, it will be Wednesday during the class. It will have 2 questions. First question, I will give you. You will be given experiment or process, and you should determine or find out. You should find out whether it is random or deterministic, and to justify that. So, for example, I will tell you the sunset time tomorrow. Is it random or deterministic? You tell me, for example, deterministic, but that's not enough. You have to tell me why it's deterministic. For example, for this specific scenario, tell me because we can know exactly when is the sunrise based on equations or based on the movement of the planets, and the very brief one or 2 sentences. So you have to tell me it's random or deterministic. For example, I can ask you how many, as we said last time, text messages that we receive every day. I'm trying to see your chat. Check in. Okay. How many messages you get on your mobile phone every day? And for example, tell me random, because I don't know in advance who is going to send me a message, and so on. So you tell me random or deterministic and justify. Muhammad, you have a question?
Doctor, will it be common knowledge, or is there something in particular should we focus on?
No, you just need to review what do you mean by a random experiment or deterministic experiment? What's the difference? Just understanding. You don't need to memorize anything. Just need to differentiate what's random, what's deterministic.
Okay, thank you.
So this will be the first question. So it will be given on Blackboard, and then you will have a window to type your answer. It's deterministic, it's random, and why. Second question will be to find the sample space of a random experiment. So I tell you, for example, we have an experiment in which we want to toss a coin twice. What will be the sample space? Again, the only thing you need to know or to understand the definition of the sample space that we gave before. So definition of sample space, it contains all possible outcomes. So you tell me, okay, it's gonna be head-head or head-tail or tail-head or tail-tail. This is your sample space, right? If you tell you the experiment that we are doing is to throw a dice, what's the sample space? You tell me it's 1 or 2 or 3 or 4 or 5 or 6, and so on. We did, remember, we did several examples in the class, and go back and review them. So you'll have 2 questions, 10 minutes. You should be able to do this even in 2 minutes. Okay. So I hope, usually first quiz, most students, they get full marks. So make sure that you be there. Yani most importantly, don't miss the quiz, and just review what's the meaning of a random versus deterministic, and what's the sample space. Okay. طيب. So let's continue what we have started last time, which is counting techniques. And before we continue with the counting techniques, why are we interested in counting techniques? Counting techniques, they tell us, or it's a way to determine or to count. That's why it's called counting techniques. To count the number or the total number of outcomes in certain random experiments. So counting techniques will tell you, if you do this experiment, you will get a total of 1,000 outcomes, or 10,000 outcomes, or 500 outcomes. So it's a way to tell us how many outcomes we will have. And why is that important? As we will see later on, most of those experiments, like flipping a coin or throwing a dice, result in what we call equally likely outcomes, or outcomes with the same chance. And hence, we can calculate probabilities easily. And we'll see how to do that. For example, like tossing a coin, you have 2 outcomes, then the probability, as we will see with each outcome, is 1 over the total number. So 1/2, half of the time you will get head, half of the time you get tail. For the dice, for example, we have 6 outcomes, then 1 over 6 is the chances or the probability for each outcome. And last time we started talking about the, let me put my phone on silence, sorry. The first one we got is the multiplication rule. Which we talked about last time, and to refresh your memory, I just try to write it again. We said for an experiment, anyone remembers the definition? With a sequence of steps where each step is done in few ways. For example, I have k steps where step 1 has n1 options, step 2 has n2 options, and so on. Step k has k options. Then the total number of possible ways or outcomes of the experiment is, as we say, or as we saw last time, is n1 times n2 times n3 all the way to nk. And we gave a few examples last time about travel from Doha to Chicago through London, and whatever, buying some food from a fast food restaurant. But let's do a more interesting example today, which is the car plate example. What's the car plate example? Let's see, here in Qatar, I assume most of you drive or plan to drive. Here in Qatar, car plates are designed to use 6 digits, right, of numbers at max. So I can ask you this question: how many different car plates we can have? So let's see. So this is my car plate, and we said we have 6 digits. Okay. So how many different car plates we can have? How many total number of car plates we might have? So we can do this in steps. It's like we are choosing the number in each digit in steps. How many different numbers I can put for the first digit? Can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right?
Maximum
10.
It can be 9.
10. Let's say, assuming that we have 0, we allow 0.
Okay.
Because we'll allow zeros at the rest, right? So also the second one can be from 0 to 9. The third one from 0 to 9, 0 to 9, 0 to 9, 0 to 9. So how many total we have? So you think of this as we are doing this experiment and selecting a number in each step. So in step 1, I have 10 ways to select the first one, then 10 ways to select the second digit, third times 10 times 10 times 10. So I can have a total of 10 to the 6, 1 million car plates, different car plates. But is this enough for Qatar? I thought we have more than 1 million cars, right? I remember seeing statistics that we have more than 1 million cars in Qatar.
There is also 5 number plate, Doctor.
Right. So in principle, the overall number, if we want to call it, 1 second. Okay. The overall number of car plates, in principle, it should be 10 to the 6 for the 6-digit plates plus 10 to the 5 for the 5-digit plate plus 10 to the 4 for the 4-digit plate plus 10 to the 3 for 3-digit plate plus 10 to the 2 for 2-digit plate plus 10 plates which has single number 0 or 1 or 2 or 3 or 5 or 6, 7, 8, 9. So this is the total number of plates that we might have, which is for sure more. It's 1,100,000 plus 10,000 plus 1,000 plus 100 plus 10. So this is again, this is for the 6-digit plate. This is for the 4 digits and so on.
Doctor, we don't have 2 digits on Qatar.
Yeah, actually, someone that the least we have is 3. So I'm not, honestly, myself, I'm not sure. So this is questionable. But in principle, you can play with this the way you want. I can say, I can ask for, if I want to ask, for example, what will be the total number of plates with a minimum of 2 digits and a maximum of 5 digits. Or I can say also, it's forbidden to have a 0 on the left. So you can replace always this one, for example, by 9. If we are not allowing 0 to be on the left. So it will be 9 times 10 times 10. So it will be 900, and each digit you lose, it will cost you 100,000 plates, which is a lot, right? Okay. Fine. To follow up on this,
for the 10 power 5, it's 5 digit, not 6 digit.
oh, 5, yes, yes, yes. Thank you. Yes. Okay. Fine. What if I can follow up with this example and say, what if we allow letters, like in Saudi, for example? So that will increase the number, right?
Doctor, in Saudi Arabia, for example, 3 to the power 26.
Let's see. So in Saudi, as far as I remember, the last time I visit, it was a year ago. Actually, I went there a year ago. I had a meeting. And we do not forget, right? These things you do not forget. So it has 3 and 3, right? 3 letters and 3 numbers. So these are letters and these are numbers. Okay. So, and they use Arabic letters. How many Arabic letters we have?
28.
Okay. MashaAllah.
They use Arabic and English, Doctor.
Do they? Okay,
yeah,
we can do several scenarios. So assuming only Arabic letters, how many we have?
28.
28.
So this one is 28, this one is 28, this one is 28, and then numbers 10, 10, 10, right? So it's 28 to the power 3 times 10 to the power 3. What if Arabic or English letters So then in this case, we'll have for the letters, we'll have 28 plus 26, right? Which is 40, 54. So in that case, you will have the total 54 to the power 3 times 10 to the power 3. What will
Doctor,
be?
what if we have we can have 3 or 2 letters and 3 numbers?
You can do whatever you want. Just place them and see how many options you have for each digit, and you can calculate it.
Okay.
But a smarter way to do this, even like in the US, a smarter way to do it is to mix numbers and letters. So each digit you can have a number or a letter. So if we have English letters, 28 plus 10 numbers for each digit.
Sir, the letters are 26.
26, right. ما شاء الله ما شاء الله ما شاء الله. نحسدكم أنا خايف أحسدكم today. So it will be 36 for each digit, and then total will be 36 times 36 all the way 6 times 36, which is 36 to the power 6, and so on.
Doctor, I have a question.
I can ask, for example, you see, you can play around this. What if we allow some special characters with the numbers, or mix, as you said, Arabic and English, or you start going into other dimensions. Sometimes, you know, how one way to do, even in Qatar, you add dimensions. What do I mean by having dimensions? Is, for example, you have the green plates for the private, whatever, the cars for transportation or something. So you can, if you have green, then you can repeat all like if with your letters and numbers you have 1 million plates that are white, then you can have an additional million that are green.
You will just add the numbers of colors, right?
Yeah, you add color. You add, for example, municipality. For example, maybe in the future in Qatar, if we have a lot more cars, we have plates for Doha, plates for the northern area, plates for, and you can repeat the numbers. What will be distinguishing is which area. For example, Doha. So one will have like a capital D in the middle, or a capital North, or you can add more dimensions. The more dimensions you add, the more plates you can create, and all of this you can calculate using the multiplication rule. Someone raised the hand.
Teacher,
Yes, doctor. Can you go back to the
what?
Can you go back to the number of cars in Qatar? Up a little bit.
Here,
doctor, is it reasonable that it's the number of cars are a very big number compared to the population of Qatar? We're talking about approximately 1 million cars for 6 digits, and if we calculate, it's a very, very big number for transportation, normal civil cars.
It is large, yes, because every family, they have a lot of cars. Myself, I have 5 cars in my home, which we don't need.
The overall number of car plates, the number will be extremely huge, even more than the population of Qatar.
Yes,
So,
no, it should not be that way
Yeah,
because you have to average this by like we have a large population of Qatar currently is around 2.7. Out of those, at least 1.2 or 1.3 are laborers who do not own cars. So it's the average number
Victor, I think
of cars per family is reasonable because we have million or more they do not have cars. But yeah, in general, the number of cars per like Qatari family or Arab family or families is large in Qatar compared to other countries. Yes. Yes.
Okay,
Any other question quickly before
thank
we
you.
move?
Thank you.
Sure. Okay. Sorry. Right. So we are done with the multiplication rule. Let's move to the next counting technique, which we call permutations. Permutations, it will have several variations. Also, we'll talk about them. Let's say given a set of objects, we want to count the number of
Teacher, this
ordered.
is recorded. This is recorded.
This is what?
Is this recorded, like the class?
It is recorded, yes.
Okay, thanks.
The number of ordered ضوعت لي حفلة التفكير انت ما شاء الله. In the middle just is it recorded. The number of ordered, given a set of objects, we want to count the number of ordered ways arrange the set. This is called permutations. So for example, what do I mean by this? I'm giving you this set, S equals A, B, C. How many different ways I can arrange them? Let's see, I can do ABC, ACB, BAC, BCB, BCA,
3 multiplied by 2.
CAB, CBA, right? So this is the number of different ways I can arrange this set. So is there a rule for this?
Yes.
Yes, this is the
We have
permutation rule. Or you know the subject?
Doctor,
You know the subject,
this is
that's
not
great.
all the principles.
Let's see, there's a rule.
This is not
there is a rule.
all the outcomes.
Give me one that I did not count.
Maybe you don't count the C. Oh no. Okay.
No, we have 3 objects and we are just ordering them. So the rule
Okay.
is given a set of size n, the total number of ordered, and ordered is the key word here, ordered ways of arranging it equals if we want to look at this
2
and
to the
apply
power of n minus 1.
let me finish and then I'll give you the time. So let's think of this as if we want to use the multiplication rule that we just talked about. So assume that I have a set of 3 here, right? Let's see how many ways I can come up with ordering this. So if to start here, let's start here. How many ways I can, how many different ways I have to put a letter in this digit? I have three. So how many? I can have A or B or C here, right? Right? So خلاص, I took one of them. How many remaining? So if I took A here,
two.
and then I have two options for the second one and one option for the third one. So it's 3 times 2 times 1, which is, in this case, n times n minus 1 times n minus 2 all the way to 1, which is n factorial.
Doctor, I have a question, please.
Sure.
When can we know when we should repeat the number or no?
What do you mean?
I mean, in the first box, we can put 3 numbers. In the second box, we can just put 2 numbers, not 3. When can I know when to repeat?
Because here we are talking about, we are putting those objects in order. Think of it in your mind. It's like you have those ABC in a box, and then you are taking one at a time without replacement. So this is similar to sampling, what we call sampling without replacement. So you take the first one. How many options when you have all of them? For the first digit, you have 3. So once you put it, خلاص, you cannot put A again in the second one and the third one, because we have a limited set of objects and we want to find the different ways of placing them. Okay. Another example.
Yeah, okay.
Yeah, Muhammad, go ahead.
Doctor, is it n minus 1 to the power of n?
N minus 1 to the power of n? No, it's n factorial. Permutation is n factorial. So here I have another example. How many objects do I have here? What's n here?
N is 4.
N equals 4, right?
Yeah. So we have 24.
So let's, I will not be able to count them, but what are the different ways? 1, 2, 3, 4. 1, 2, 4, 3, for example. 1, 3, 2, 4. 1, 3, 4, 2, and so on. So in order to be able to count them, it's a bit headache. So we just use the rule. According to the rule, the number of ways is 4 factorial, which is 4 times 3 times 2 times 1, which is 24 different ways of ordering this set. So permutation will tell you how many ways you can order a set of objects where order matters. So the golden rule here, keep in mind with permutations, order matters. Because as we'll see in combinations, order does not matter. Right. Let's move a step forward, which is a bit more interesting, which is permutations of a subset or of subsets. Which is given, again, given a set of size n Now I don't want to order the whole set. I want to order part of the set only. We want to select a subset of size R, which is less than or equal to n, and then find out the number of ordered ways. So for example, let's see an example and then we state the rule. Let's see S equals A, B, C, D. So n equals 4. And now I'm telling you how many, if I take only 2 of these, subset of 2, how many different subsets of size 2 we can do out of this set. So let's see, I think we can do it. It's AB, AC, AD, BA, BC, BD, CA, CB, CD, DA, DB, DC. As you can see here, we have, for example, AB and BA. They are different because order matters. Also, we have BC, CB, and so on. So what's the rule for that? How many do I have? The rule, so the rule is what we call P, permutation of a set of n and having a subset of R. The rule is n factorial over n minus R factorial. And this is a rule that you have in mind. Abdullah, go ahead.
So I get how whether the order matters or not will differ the answer, but what I didn't get is how can we determine from the question whether we can like, for example, if we're gonna use 2 letters, how can I know if I can use BB, for example, or DD or CC, because they will increase the probability.
No, we deal with each one as one object. You cannot order, you cannot, the set has only one A. You cannot have a subset of 2 A's in it, right? And you just deal with the objects in the set. If I will mention like very shortly the case if you have multiple A's or multiple B's. Well, how can you deal with that? But now you do not have more. You have only one A. And as I said, this is equivalent to sampling without replacement. Sampling with replacement is a totally different game. Here, permutations deals with objects that are ordered, that are not repeated. You deal with only the objects that you have in the set. Okay. Fine. Again, how can, if you want to prove this, like we can prove this using also the multiplication rule. We can prove this using, or before proving it, let's see if, let's go back to the example and see if we apply this rule. So in this example, n equals 4 and r equals 2. So, which means that I have 4, 2, which is 4 factorial over 4 minus 2 factorial, which is 4 factorial over, let's see. So this is whatever, 4 times 3 times 2 over 4 minus 2 is 2, 2 times 1, 2 times 1, which is 12. 4 times 3, which is 12. And indeed, here we have 12 subsets of the set itself. If we are ordering the whole set itself, it will be n factorial, which is 4 times 3 times 2 times 1, which is 24, right? 4 times 3 times 2 times 1 is 24. So you can have A, B, C, D, A, B, D, C, A, C, D, B, and so on. You can list all 24 options or scenarios. Okay. Ibrahim.
Doctor, would you ask us a question where the order doesn't matter?
Yeah, we'll talk about combinations. Combinations is when the order does not matter. So we'll come to that.
All right, thank you.
Okay. We'll cover that. Let me, okay. Fine. So note that
Doctor, what's the
Sure. Go ahead.
Yeah, what's the advantage of permutation exactly?
It will tell you how many different ways you can order a set, the objects in a set. In practical applications, we can mention some examples, and the homework we will do some examples. But this is come very often in many applications, as we will see. Okay, so as I said, we can also use the permutation, the multiplication rule for the subset ordering to prove this equation. So basically, how many times number of ways to select the first object. So now I have n. Let's say I have one second. Okay, let's do it this way. So I have n, and then I want to order only 3 or r of them. So how number of ways of selecting the first object? Number of ways selecting the first. How many different ways I can select the first element? N, right? N. Type. How many ways I can select the second?
N-1, doctor.
N-1. And how many ways to select the third? N-2.
Doctor, this will end at N-N?
No, the rth. Let's see, the rth one. It will be what? N minus r. N minus r plus 1. Right? So if I'm interested, because the second one is n-1, the third one is n-2. So the rth one.
Yes, makes sense. You don't want to
n minus r plus 1. So according to the multiplication rule, the total is equals n times n-1 times n-2 all the way to n-r plus 1. And this is what, so is this equivalent to this? Let's see. So based on the multiplication rule, Pnr as we show, it's n times n-1 times n-2 n minus r plus 1. I can multiply the denominator and numerator with the same numbers, right? So here I can do n minus r times n minus r minus 1 all the way to 1. And the bottom also, I can do n minus r minus 1 all the way to 1.
Doctor, what is this?
One second. I will write it in a different color. This is math. So now we proved this based على multiplication rule, right? Because I have n times for the first one, n minus 1 times n minus 2 all the way to n minus r plus 1. This is the number of ways I can order r, a subset r, out of a set of size n. But the rule is I gave it with this equation. So I want to show that this equation is equivalent to this. So I came to this equation and I multiply both up the numerator and denominator by multiply both. Yeah, if you have a certain ratio, you can multiply the numerator and denominator with the same number, right? So n minus r minus 1 all the way to 1, and the bottom n minus r minus 1 all the way to 1. So now I will come to you, Abdullah. Just let me write this. So what do I have in the numerator here? I have n times n minus 1. So what do I have here? N times n minus 1, n minus 2, all the way to 1. So this is n factorial. And in the denominator, what do I have? I have n minus r minus 1, all the way to 1. So this is n minus r factorial, which is equivalent to the equation above. Yes, Abdullah.
Doctor, I didn't understand. What do you mean by n minus r plus 1? What's the point of considering this?
Here I'm trying to just prove this equation using the multiplication rule. So assume you have n objects and you want to order r of them, only subset of r. So what I wrote here is how many ways I can select the first one? It's n, right? You are just starting, so you have n objects, you can pick any one of them. Once you pick one of them, you move to the second element, you have n minus 1. And then when you move to, so this is n minus 1, n minus 2, all the way. As you move on, you subtract 1. So when you move to the rth place, how many choices do you have? You have n minus r plus 1 choices. Why? Because the second place is n minus 1. The third place is n minus 2. So the rth place is n minus r plus 1. It's not n minus r. It's n minus r plus 1. It's always like second place is n minus 2 plus 1. Third place is n minus 3 plus 1, which is n minus 2. That's why the rth place is n minus r plus 1. So to get to the permutations, you have to multiply all of those, which is n times n minus 1, n minus 2, all the way to n minus r plus 1, which gives you the permutations. I can rewrite this in a nicer way, and we can prove that it's equivalent to n factorial over n minus r factorial. Okay, let's pause for a couple of minutes and do the absence, and then we continue. So please log into your Blackboard. I will have 2 minutes only to for you to check in. I still did not start it. One second, it's still loading. Okay, start check-in. I just so you have 2 minutes, please. Don't tell me that you couldn't. So go to Blackboard and do the check-in.
Doctor, proving a
Yes.
rule or any proving is good for the fundamentals, يعني, to understand it. Will we be asked to prove anything?
Not in the exam. Maybe in the homework case, but in the exam, I will not ask you to prove.
Tamam,
Don't worry. Okay.
Doctor, what's the another way? There is a multiplication and permutation.
No,
The permutation.
Permutation, and then we'll talk about combinations where order does not matter, and we'll see how to differentiate between them.
My question is permutation. Permutation is a branch of multiplication row or another way.
No, it's another way. They are all linked together.
It's another way.
It's another way. Yes, multiplication rule, as I said, just think of it as you doing things in steps, which we utilize with permutations. But permutations, خلاص, don't think about it of doing things in steps. Think about it that you are dealing with a whole set, and then you start playing around. I want to order the whole set. I want to order part of the set. I want to order the set if we have similar objects, as we will see right now. So think always of permutations and combinations, that you are doing, counting how many subsets we can have, if order matters or if order does not matter. And things should be clearer in your mind once we do the combination very shortly. شباب 10 seconds باقي check in. Make sure you check in. I think it's over, so I hope you all had the chance to check in, and let's do another variant. So again, we started with permutations for the whole set.
للحين أنا ما سويت تشيكن، ثواني بس.
راح خلاص, it's over, closed.
كان عندي داخل عن طريق اللابتوب.
Send an email to Sijoy, not to me.
إن شاء الله.
What's your name?
حمد الهاجري.
Hamad, send an email to Sijoy and copy me. As per Dr. Mazen, he asked me to send this email. هو بيحط لك الحضور. I will change the setting to be 3 minutes next time, but please make sure that you can follow this. Anyhow, so we
sorry.
Yes.
I was also not able to check in.
Okay, today is the last thing that I will do this. Send an email to Sijoy, the TA, and copy me, and he will put you manually. Okay, so permutations, we started. We want to order the whole set of size n, so the number of permutations is n factorial. If we are doing a subset, then the number of different ordered subsets is n factorial over n minus r factorial. And now what happens if, like one of you mentioned, that I have a set which has some similar objects. I have 2 or 3 A's in the set, or 2 B's in the set. So let's start with an example. Given S, for example, has A, B, B. How many? So N equals 5. And I want to see how many ordered sets of size 2 I can do. So in this case, I have AB, BA, right? That's it. If R equals 2. How about if R equals 3? I can have AAB, ABA, BAA, and then AAA, and then ABB, BAB, BBA, right? This is the only thing I can do.
Doctor, in the first one, I think there will be more. What about the AA and BB?
Right, you're right. AA, BB. Yes, thanks. So this is for R equals 2. This is for R equals 3. If I'm not mistaken, maybe I missed something in the second one. So AAA, AAB, ABA, BAA, ABB, BAB, BBA.
You missed triple B.
I missed what?
Triple B. BBB.
Only 2 Bs. I don't have 3 Bs.
Oh yeah. Okay. So
Okay. So in this case, how can I find how many outcomes I have? We have a rule for that, which is given a set of size n and similar objects of sizes n1, n2, all the way to nr, then the number of ordered. Actually, the rule does not cover those cases. Those cases we are not covering. Maybe you can look at how many we can have yourself, but we'll do for the whole set. The number of ordered ways of the set is n factorial over n1 factorial, n2 factorial, n3 factorial, all the way to nr factorial. So the example for this is, if I have a simple example, A, B, and I want to order the whole set. So the whole set is AAB, ABA, BAA. That's it, right? I do not have of size 3. So n equals 3. In this case, I have n1 equals 2, n2 equals 1. So number of permutations factorial over 2 factorials times 1 factorial, which is 3 times 2 times 1 over 2 times 1, which is 3. Try to find this yourself if I want to do a subset of this. Okay, so done with permutations. Let's do combinations. So again, permutations, order matters. AB is different than BA. Okay. So the third counting technique that we will cover is what we call combinations. Combinations is exactly the same as permutations, but order does not matter. So the definition is, given a set of size n, the number of subsets of size r when order does not, let me write it in red, size when order does not matter is, and we call this CNR. It's n factorial divided by n minus r factorial, and the only difference is that we put r factorial in the denominator. And why is that? Because r factorial is the number of ways to order subset R. Let me define what do I mean by this. Let's do an example first, and then we'll go back to this definition. So an example. Again, if I have a set of A, B, C, so n equals 3. I want subsets of size R equals 2. So how many subsets I can have of size 2?
Only 2.
I can have
No,
AB,
3. You can have 3.
AC, BC, right?
Yes.
So note here, we don't have BA, because BA is the same as AB. Order does not matter. Or CA, or CB. Order does not matter. So if we apply the rule, let's apply the rule. So we want C 3, 2. So this is 3 factorial over 3 minus 2 factorial times 2 factorial, which is 3 times 2 times 1 over 1 factorial, which is 1. 2 times 1, this with this, so it will give you 3. Indeed, we have 3 subsets. Let's do another example from our class, for example. Another example. And let's compare permutations and combinations. So in our class, I guess in our class we have 45 or 44 students. I did not check. I can check really quick just to have the example correct. So we have we have 42 students. We have 42 students in our class. We have 42 students. Okay, but assume that I ask you this question: how many different projects, groups of size 3 we can form out of the class? And assume that I tell you, okay, form a group of 3 students for each project. How many different groups we can have?
14.
So in this case, will order matter or it will not matter?
Of course it will not matter.
Of course it will not matter, right?
Yes.
It will not matter. Why? Because the group that has Ali, Muhammad, and Nasir is the same as Nasir, Ali, Muhammad. Is the same as Ali, Muhammad, and Nasir, right? So order here does not matter. So we will have C 42 size 3, which is 42 factorial over 42 minus 3 factorial times 3 factorial, which is, so this is, again, let me run one more step, on the 39 factorial times 3 factorial, which is 42 times 41 times 40 times, I can write it this, 39 factorial, على 3 times 2 times 39 factorial. So this cancels with this. This is 20. This is 1. This is 1. 14. So equals 14 times 1, 4 times. This is how many different groups we can have. So here, let me write it here. Order does not matter. A group of Ali, Muhammad, Nasir is the same as Muhammad, Ali, Nasir, etc. However, if I ask that each group should have project leader, secretary, for example, and not secretary, project will not have a secretary, maybe. Project will have time keeper, let's say, and programmer. Then how many different groups? So now you can think of it this way, like if this group, I have Muhammad as leader, Ali as timekeeper, Nasir as programmer. This is different than.
It's the same, but we'll make it like the order matters, like the previous examples.
Yeah, so timekeeper. So here order matters, right? Because when Ali is just programming, Nasir is leader. So here, in this case, now order matters, which means now it's P42 3, which is 42 factorial over 42 minus 3 factorial, which is 42 times 41 times 30. So it's 6 times more than the number of groups in the previous case. And as you can see, the difference between permutations and combinations is just R factorial. R factorial is the number of ways. For example, here, how many ways I can distribute Muhammad, Ali, and Nasir on the leadership, timekeeping, and programming? It's 3 factorials, right? R factorials. So I can have 6 ways of putting Muhammad as a leader, or Muhammad as a programmer, or Muhammad as a timekeeper, then Ali and Nasir. And this is the difference. If we want to order the subset, we don't divide by it. If order does not matter, then we divide by R factorial, which is the number of different ways of ordering the subset.
Doctor, permutation order.
I should mention here that in permutation, order matters. In combination, order does not matter. Let me write that, recall that. We can write the combinations as n choose r, which is n factorial على n minus r factorial r factorial. Also, we call that 0 factorial equals 1. These are things that you should remember. I think we are running out of time. I wanted to cover one more example, which is probably we'll start next time with it, which is the birthday example. Want to see out of you what's the chances that two of you will have the same birthday. Try to think about it or read about it. It's a very famous problem in probability. Try to come up with numbers. What's the chances that two of you out of a class of 42 students will have the same birth date? And you should find out that this is very high probability, very good probability, I would say, that two of you will have the same birth date. But I will do it next time. I have only 1 minute, so there is no time to do it. So next time we'll have quiz 1, please. And usually I have quiz 1. Usually students, most of them they score full mark. It's an easy quiz. So make sure on Wednesday you attend. Don't miss the class and tell me to give you a makeup quiz, because I will give you a hard quiz. So just come to the class. I'm sure you can do well in the quiz. It will be during the class. Yes, on Wednesday, next class.
Actually, how long will it be for the
10 minutes.
Okay.
Teacher, will this be uploaded on Blackboard?
Yes, today's lecture and notes will be uploaded to Blackboard.
Thank you, Doctor.
Thank you. Have a good day.
جزاك الله خير دكتور.
حياكم الله.